Are you struggling with filtering dictionaries that have tuples as keys? If so, you're not alone. Today, we're diving into how to efficiently filter dictionaries with variable length tuple keys. I understand how challenging it can be to manage large dictionaries, especially when they contain thousands of entries. It's frustrating when you need to filter through them quickly, but find yourself stuck with slow performance. Here's the specific question we're addressing today. One user asked, what is the most efficient way to implement a filter function for a dictionary with keys of variable dimensions? They need a solution that allows them to filter based on certain indices of the key tuples. Sound familiar? Let's explore this together. To understand the issue, we need to recognize that filtering dictionaries with variable length tuples can be significantly slower than filtering those with fixed dimensions. This is due to the complexity of checking each key against the filter criteria. Stay with me. By the end of this video, you'll have a solid understanding of how to optimize your filtering function for better performance. To efficiently filter a dictionary with arbitrary length tuples as keys, the user can create a function that utilizes a list comprehension. This approach will help in quickly matching the filter criteria against the dictionary keys. Next, the user should ensure that the function checks each dimension of the tuple. This is done by using the zip function, which pairs elements from the filter tuple and the dictionary key tuple together. Now, the user can test the function with various filter tuples. This will demonstrate how the function returns the correct keys based on the filter criteria provided. Finally, the user should consider performance optimizations. If the dictionary is large, using a set for the keys can improve lookup times, making the filtering process faster. Fun fact, did you know that the speed of data processing has increased exponentially over the years? Yet we still face challenges with efficiency in our code. Now, let's look at the answers provided by other users. An alternative approach suggests leveraging Python's strengths by avoiding complex nested iterations. Instead, it recommends using simple iterations and comprehensions for better performance. The user proposes building a lookup dictionary that indexes each key by its position and value. This allows for fast filtering using set intersections, significantly improving performance. This method efficiently handles tuples of varying lengths and allows for both general and specific filtering, with impressive timing results for large datasets. That's it for that answer. Let's take a look at another one. An alternative approach to filtering dictionaries with tuple keys involves several optimizations. First, instead of using the dict.keys method, you can iterate directly over the dictionary. This simplifies the code and improves readability. Next, the user suggests creating separate modules for better organization. This includes a preparations module for generating test data, a functions module for the filtering functions, and a main module for benchmarks. To enhance performance, the user recommends skipping checks for indices with none values in the keys. This reduces unnecessary comparisons and speeds up the filtering process. Finally, using NumPy can further optimize the filtering process. By converting the dictionary keys into a NumPy array, you can leverage efficient array operations to filter the keys based on the provided criteria. That's all for that response. Let's see what someone else had to say. An alternative approach suggests optimizing the filtering function by eliminating repeated computations. Since all entries in the dictionary have the same length, you can calculate that length once before the loop. This can improve performance by about 20%. For even greater speed, the user proposes using the eval function to dynamically create a filtering function based on the key length. This method can make the filtering nearly as fast as static length filtering. Now, let's shift our focus to a different response. An alternative approach involves defining a function to check if two tuples match based on specific conditions. First, retrieve the dictionary keys. Then, create a function called isMatch that compares two tuples. This function uses a helper to check if each element is equal or if either is none. Finally, use a list comprehension to filter the keys based on the match function. Here's a pro tip. If you frequently work with dictionaries of varying dimensions, consider creating separate functions for each dimension. This can save you time and improve performance in the long run. And there you have it. With these strategies, you should be able to filter your dictionaries more efficiently. If you found this video helpful, please subscribe for more tips and tricks.